So a photoemission is the release of an electron when you shine light upon a surface. So that surface can be a metal surface, it can be any surface at all. Light of a certain frequency will eject electrons from quite a few different materials. That's the basis of how things like solar cells, LDRs, photodiodes and also automatic doors work. You know, the ejection of electrons creates a flow of electrical current, and that's basically what can be used to power all sorts of different things. So in order to investigate that, we had a look at something called a gold leaf electroscope. Now a gold leaf electroscope is just a really sort of primitive voltmeter. It's a way of measuring you know, the difference in charge between 2 points. We didn't connect it to a supply, we just used rods which hold a certain charge, either positive or negative, and then shone lights onto the surface of the electroscope to see if we could eject charges from it. So we start off with a positive charge. So that was the polythene rod, the white rod that I rub with a kind of duster cloth and then hold it above the surface here and can basically cause the electroscope to have a fully positive charge. When we shine white light onto that of varying irradiance, so we change the irradiance by moving the light closer and further away. It doesn't matter how much irradiance we have, how much radiation is falling per unit area. There's no change at all. Everything just stays as is here. We use ultraviolet light, again of varying irradiance, so we move it as close as possible. No change at all either with ultraviolet light on the chromium surface. So we change the chromium surface for zinc, and even with UV and ultraviolet light of varying intensities, there's no change at all there. So we can conclude from that, or did conclude from that, that positive charges cannot escape the metal surface. So we're not seeing any change at all here. We moved on then to charging the electroscope negatively. And when you charge the electroscope negatively, we do see something different happening here. First of all, white light on the negatively charged electroscope, there's no effect. Increasing the irradiance of the white light, in other words, more waves falling per unit area, still no effect. Ultraviolet radiation or ultraviolet light on the negatively charged electroscope, no effect. These are all with the chromium surface, the natural surface of the electroscope. Change that surface for zinc, pop a little circle of zinc on the top instead, shine the UV light on, the leaf starts to fall. So because the leaf starts to fall, we know that there must be some sort of negative charge that is escaping here, because the negative charges can then spread out a bit more. Remember that the leaf only stands up because it's repelling against the other charges that are there. If we increase the intensity of that, in other words increasing the irradiance by moving the light closer to the zinc plate, then it falls more quickly. So the more intense the UV is, the more electrons we are ejecting. So the only way that we could get rid of charges from this metal surface was if it was zinc and if it was of a certain frequency, in other words ultraviolet light. White light just didn't do the trick. So we really said that from all our diagrams there, we could conclude that positive charges couldn't be ejected, electrons can, but only from the zinc. And the more intense that is, the more electrons are ejected because the leaf falls slowly, even faster. Sorry, when intensity is higher. And that leads us to something which is called the quantum theory of light, which basically tells us that light isn't always necessarily a wave as we think it has been up to this point, but it can sometimes act as a particle.